Good morning, dear children. I hope all of you fit and fine at your home. Today we will start our annual course. So, dear children, kindly open your book, page number 113. Chapter 11, Motion and Measurement. From this chapter, we will learn about history of transport, motion and its types, and measurements. First, we discuss about history of transport. In earlier times, people did not have any means of transportation and they covered long distances on foot and carried loads on their back. With time, human beings domesticated animals like donkeys, horses, oxen, bulls, etc. to carry loads. Later, they began to ride on their back and used them as modes of transport. To travel through water routes, they initially tied up logs of wood and floated them in water. Later, they gave a curved shape to logs to make boats of wood. The invention of wheel completely changed the mode of transport. Human beings made carts which were fitted with wheels. The animals were then made to pull the carts. This made the lives of people comfortable. In the 19th century, the invention of steam engine revolutionized the mode of transportation. In place of animals, engines working on the power of steam were made to pull the carts or bogies fitted with rubber tire wheels. So, 19th century onwards, we use the engines. The invention of steam engines helped in developing the mass transport system. With the invention of the aeroplane in 1903 by Wright brothers, travel across the oceans was made possible. This also reduced the time commonly spent to reach far away places. So children, Wright brothers invented the aeroplanes. Modern means of transport like car, buses, scooters, etc. have changed the trend of the transport in present times. Then motion and its types. What is motion? An object is said to be in motion when it changes its position with respect to time. For example, a speeding car is in motion. Then what is rest? The objects which do not change their positions with time are said to be at rest. For example, a wall of house is at rest. Consider two people sitting in a compartment of a moving train. Both of them are at rest with respect to each other. But the same two people are in motion with respect to the objects outside the train. From the above two examples, we can conclude that the same objects can be considered as stationary or in motion, relative to their reference point. Then what is reference point? An object is said to be at rest or in motion relative to a fixed point, and that fixed point is known as reference point. It is because of this reference point that state of rest and motion are regarded as relative. Depending on the ways in which the position of a body changes, its motion can be classified into the following types. They are translatory motion, rotatory motion, oscillatory motion or vibratory motion, then periodic motion. First we discuss about translatory motion. What is translatory motion? If a body moves as a whole and every point on it moves the same distance in a given time, it is said to be in a translatory motion. For example, movement of a car, throwing of a ball, opening of a door, etc. Then it is further divided into three types: rectilinear motion, curvilinear motion and random motion. One by one we will discuss. First we will see rectilinear motion. When a body moves in a straight line, it is said to be in rectilinear motion. For example, motion of a car along a straight road, falling off a stone, etc. Then what is curvilinear motion? When a body moves along a curved path, it is said to be in curvilinear motion. For example, a car moving along a curved path, throwing of a ball, etc. Then random motion, a type of translatory motion in which a body keeps changing its position in a disorderly manner, is termed as random motion. For example, hovering of a honeybee on a flower, motion of a hockey player in field, etc. Then rotatory motion, when a body rotates on a fixed axis without changing its position, it is said to be in rotatory motion. It is also known as circular motion. For example, a ceiling fan, a spinning top and the movement of earth on its own axis. Oscillatory motion and vibratory motion. The to and fro movement of a body about a fixed position is termed as oscillatory motion. For example, movement of a pendulum, a swing, etc. When oscillation takes place at a rapid rate, it transforms into vibratory motion. For example, strings of an instrument, movement of our vocal cords and ringing alarm clock. A vibrating body produces sound. Then uniform and non-uniform motion. A motion in which a specific distance is being covered in a particular period is called uniform motion. For example, soldiers in a march past exhibit uniform motion. Then non-uniform motion, a motion in which speed differs with respect to time is called non-uniform motion. For example, a toddler walking or running shows non-uniform motion. Then periodic motion. Motion which repeats itself after a fixed or regular interval of time is termed as periodic motion. We see the sun in the morning due to periodic motion of earth. When a ball is dropped, it bounces in regular motion. Motion of a pendulum are some examples of periodic motion. Some rotatory motions are also periodic motions, and some or all oscillatory motions are periodic motion. Then combinations of different types of motions. In daily life, objects undergo a combination of various types of motions. Some examples of such motions are given below. The motion of a ball rolling on the ground is a rectilinear and rotational motion. Then the motion of earth spinning around the sun is translational, circular and periodic motion. The movement of an object attached to a suspended spring is a translational and oscillatory motion. Measurement. Measurement involves the comparison of some unknown quantity with a fixed known quantity. This fixed quantity is called unit. This unit is chosen according to convenience. Measurement has two parts, magnitude and unit. For example, if we consider weight of a man to be 50 kg, then 50 is the magnitude and kg is the unit. Need for measurement. Why we need to measure? Our judgment regarding length, area, mass and time might go wrong and mislead us from the actual reading. Therefore, in order to make our judgment accurate and reliable, measurement is required. Then units and tools of measurement. Earlier, people used to measure short distances using their foot, handspan or arm length. Measuring length using these units is inconvenient because each individual has a different handspan, foot length and arm length. These units were used initially because of lack of an appropriate measurement system. In order to measure length accurately, a divider, a meter scale or an inch tape is used. Length is measured in meters, centimeters, feet, inches, etc. Initially, people used to locate the position of stars in order to have an idea about time. Later on, they devised sand clocks, sundials, analog and finally digital watch to measure time. Time is measured in seconds, hours, days, months, years, etc. Mass of a substance is measured using balances such as spring balance, beam balance and weighing machine. Mass is measured in kilograms, grams, milligrams, pounds, etc. Children, you should remember these units. Standard units of measurement. And discussed in the previous section, people in early times used different units according to their convenience, and these units differed not only from place to place but from person to person. Therefore, a common system of measurement was designed by a group of scientists, and they named the new system as metric system. Now, there is a global standard, the International System of Units, or the SI units. The modern form of the metric system. The metric system of unit is universally accepted by scientists all over the world to measure physical quantities. Then units of each quantity have subunits. For example, 1 kilogram equal to 1000 grams, 1 meter equal to 100 centimeters, 1 hour equal to 60 minutes. Thus, gram is the subunit of kilogram, then centimeter is the subunit of meter, and minute is the subunit of hour. Here one box is given, measure and SI unit. The SI unit of mass is kilogram. The SI unit of length is meter. Then the SI unit of time is second. Then the SI unit of temperature is Kelvin. Children, you learn this box. This is your homework. Measurement of length. The meter is the base unit of length in the SI unit. It is the distance between two lines on a standard bar composed of an alloy of 90% platinum and 10% iridium, measured at 0 degree Celsius. Architects, builders, fashion designers, engineers, physiotherapists, mathematicians, physicists, and students need to measure length of a building, length of a cloth, height of a person, length of a machine, or even length of a line for the purpose of their work. In order to accomplish this, they use different devices such as ruler, measuring tape, meter rod, etc. to measure the length. Let us now see how do we measure length of a given object. Some multiples and sub-multiples of meter are given below. 1 decameter equal to 10 meter, 1 hectometer equal to 100 meter, 1 kilometer equal to 1000 meter. Children, already you learnt these units in your math class. Again we recall. 1 meter equal to 10 decimeter, 1 meter equal to 100 centimeter, and 1 meter equal to 1000 millimeter. So children, you learn these multiples and sub-multiples. Then correct measurement of length. Accurate measurement of any object is very essential. You can imagine what would happen if your tailor does not make accurate measurements. To make accurate measurements, we need a proper measuring device. The choice of the measuring device depends on the size and shape of the object and the degree of accuracy needed. Some commonly used length measuring devices are ruler or meter scale and measuring tapes. You just read how you measure. Okay, this is about your chapter motion and its measurement. Again, you read this lesson at your home properly. Thank you.